Hello and welcome to video 9.1, video number 3 of 4 videos. In this video, we're going to be talking about probably the most important topic we'll cover in 9.1, which is the unit vector. In video 4, we'll look at an example, which obviously the application is important as well, but it's understanding this basic concept of what are we talking about with the unit vector. Not just in this class, but if you're going on to like a physics class, something at that point, you'll be talking in terms of vectors, and specifically the unit vector. So we have the following definition. A vector of length 1 is called a unit vector. And the two we're going to be talking about, so the two useful unit vectors are the two unit vectors I and j. And these are defined by the following. So I is the vector that has values 1, 0. So I is our left and right movement. If it's plus I, that means we're talking about going to the right. If it's minus I, it means we're moving to the left. J has the values 0, 1. So J is our up and down movement. So if it's plus J, we're going up 1 unit. If it's minus J, we're going down 1 unit. So if we were to draw this on a graph, our I value is just a vector that moves 1 unit over to the right. If it's plus I. If it's minus I, it would be going to the left. And J is a vector that moves straight up or straight down if J is negative by 1 unit. And obviously we can have multiples of those. If we have 3I, it means we move 3 units over to the right. So any vector can be expressed in terms of I and j. And we do that as follows. So any vector can be expressed in terms of I and j by the following. So we say that the vector v, which has its components a and b, is the same thing as saying ai plus bj. So a units left or right, b units up or down. So for example, if we want to write the vector u, which has components 5, negative 8, in terms of I and j, we would have the following. So u has the components 5, negative 8. So this is the same thing as if we said 5i minus 8j. So when we see 5i minus 8j, it means from the point where we're starting, we're going to move 5 units to the right, 8 units down. We connect the starting and the ending point. That gives us the vector notated by 5i minus 8j. Okay, so the next topic here within this video has to do with horizontal and vertical components. So there's a couple formulas that are associated with the horizontal and vertical components. In the past, I'll be honest with you, this is a re-recording of this section of videos. I used to have these formulas, but the problem is that they don't work 100% of the time, or maybe what I should say is they work 100% of the time given certain conditions. And so I don't like to give you guys formulas where you have to now think about it, okay, can I actually use this formula, or is this one of the situations where I cannot use the formula? You guys know enough trigonometry now that if I give you a triangle, you can figure out sides, left and right, up or down, using your trig functions. And to be honest with you, I would rather, going forward, you figure that out. If you go through the book, if you read the book, and as you follow along with the notes or to supplement the notes, you'll see these formulas, you'll see some examples. In the example that they give you, these formulas apply. But the issue is, there are situations where these formulas don't apply as written, and if you try to apply them as such, you're going to end up with your I and your J values reversed. And I don't want that to happen to you. So we'll look at an example that would typically use the formulas, but instead we'll figure it out with our trigonometry and see how it works out instead. And again, for examples, for applications, I would rather you do it this way instead. Just use your trig knowledge, your basic trig knowledge, rather than trying to apply these formulas. And again, I suppose it's a good thing because for the final, it's 2 less formulas that you're going to have to memorize. You can just apply the trig knowledge that you have. So we have the following. V has length 8. So vector V has length 8 and direction pi over 3. We want to find the horizontal and vertical components and then once we have that, write V in terms of I and J. So, let's talk about what are the horizontal and vertical components. What is it talking about? It's simply talking about the horizontal component is how much left and right we're moving. So if we go back to this example, basically our horizontal component is a 5, meaning that we're moving plus 5 units to the right. The vertical component is minus 8. So it's telling us we'd be moving down we move down 8 units, thus the negative sign. So if we draw this vector V, so it has direction pi over 3, which is what? That's our 60 degrees, right? So if we're starting at the origin, moving in a direction, so from the x-axis moving up, pi over 3, and it has length 8. So what we're trying to figure out here then, if we draw this line down so we hit the x-axis and form a triangle, our horizontal components, let's call it h, is how much left or right we are moving. The vertical, so if we call it v, is how much up or down we're moving. And we have to associate the proper signs with it to make sure we're indicating whether we're moving left or right, whether we're moving up and down. So you have a couple ways to do this. So pi over 3 is what? Well, that's 60 degrees. So this is one of our special triangles, which we have talked about in previous videos. You could do it that way. You could just use special triangles. If you're not comfortable with it, if you want to actually figure it out by the trig method, that's fine. I would recommend that too if you're not comfortable with the special triangles. So if we want to figure out our value for h first, well, h would be what in terms of our trig functions? So if our theta is 60 degrees, we have what? We have an adjacent side and we have the hypotenuse of this triangle. So what trig function uses adjacent and hypotenuse? It's cosine, right? So we have cosine of 60 is equal to adjacent h over hypotenuse 8. So if we figure that out, cosine of 60 is what? That's equal to a half. So this equation basically says we have 1/2 is equal to h times 8. So if we want to solve for h, if we multiply both sides by 8, 8 times a half is 4. The 8's cancel over here. So that means that our value for h, how many units left or right we're moving, is equal to 4 units. Similarly, for the y, if we're using this angle inside the triangle is 60 degrees, we have opposite and hypotenuse. So that's what? That would be sine of 60 is opposite v over hypotenuse h. Sine of 60, square root of 3 over 2. So that means we have square root of 3 over 2 is v over 8. If we're trying to solve for v, we multiply both sides by 8 again. The right side cancels out, so that gives us our value, v, our variable. And over here, 8 cancels with 2, gives us 4, so we have 4 times the square root of 3 for our vertical value. So what that means, again, think about these vectors, is if I start and I get pushed 4 units to the right, 4 root 3 units to the top, it puts me right at this ending point, which is 8 units away from where I started. So that's the first part, our horizontal vertical components. Then we want it in terms of I and j, so all we do is just put I in front of our horizontal, put j in front of the vertical. So we get 4i plus 4 square root of 3j. So that answers this problem. What's the horizontal vertical component? Horizontal 4, vertical 4 square root of 3. Write it in terms of I and j. Well, we just put the I with the horizontal piece, j with the vertical piece. If you need to go back, review it, please do so. We'll move on to one more example here, and then that'll conclude video 3. So in this case, this example, we have the following question. We want to find the direction of the vector u is equal to negative square root of 3i plus j. So if we draw a coordinate system here, now we want to draw the triangle that corresponds to where this vector goes. So our I is our horizontal piece, and it's negative square root of 3. So that means we move which way? It means we move over to the left, and then j is positive, so we're moving up. So we have some point here in quadrant 2. So if we draw that triangle, our horizontal component is negative square root of 3. So these are similar to our build the triangle problems, where the side of this triangle is negative square root of 3, but really what it just means is we're moving that many units to the left. And then this is sort of an invisible 1 here, so don't forget about that guy. So we're moving up 1 unit. Now, this is the tricky part with this one. So we're trying to find the direction of where this heads, but don't forget we always start on the x-axis going to the right. So what we're really trying to find out is what is this value of theta, starting at x, coming all the way around. So what we can do here is figure out this theta in here, so let's call it theta star. And once we know the angle inside this triangle, then we can do what? We can just subtract it from 180, and that'll tell us how far we came around to get to that vector u, which is this one here. So let's figure out that theta star. And again, this is using our basic trig information, SOHCAHTOA. So if this is our theta, what pieces do we have? We have opposite and we have adjacent. So that means what? That means tangent of theta star is opposite, which is 1, over adjacent, which is negative square root of 3. So that means tangent of theta, if we rationalize this guy so that it looks like something we're familiar with, this is what? Negative square root of 3 over 3. So negative square root of 3 over 3, where on the unit circle does tangent have that value? Well, it would be what? It's our pi over 6 value here, right? So that means our theta star would be pi over 6. But in quadrant 2, it has what? It has theta star then would be 5 pi over 6. In quadrant 1, pi over 6 is square root of 3 over 3. So over here, so theta star, so actually let me step back here. So if we're trying to figure out this triangle here, this length of this side, we're going to use the positive value, right? Because we're finding inside there. Otherwise, it's giving us all the way around. So theta star then, the value inside the triangle, is related to square root of 3 over 3, which is theta star would be pi over 6. Or what? 30 degrees, right? So if the value inside that triangle is 30 degrees, then the red, the piece coming all the way around, would be what? It would be 180 minus 30, which is 150 degrees. Or if you want to have it as radians, it would be what? 5 pi over 6. So again, we're trying to first figure out this angle inside the triangle. We can do that just by using the absolute values of these lengths, square root of 3 and 1. So we set up that equation that tangent angle is 1 over root 3, which when we rationalize it is square root of 3 over 3. So our theta star becomes pi over 6, which is 30 degrees. So we can subtract that from 180, which gives us either 150 degrees or 5 pi over 6 radians is the direction of this vector. All right, sorry for that little bit of confusion. Hopefully it's clear now. If not, certainly ask me about it during class period when we review this section, and I'll just try to clear up any confusion there. But basically, we're finding the angle inside the triangle so that we can figure out the bigger angles starting at the x-axis. That concludes this video. We'll see you guys in video 4.